And when you start looking at apps from a computer science abstraction perspective, you immediately realize that there are kind of apps that people communicate with other people. They were never supposed to be public, and I'm glad they're not public. Be it Facebook, be it WhatsApp, Snapchat, you go on, okay? And those apps have their place. And people spend a lot of time in them if you read the ComScore report and whatnot. Then there's a class of apps that require the computing power and the rendering power of the processor to deep degrees. Gaming apps are examples of that, or even possibly entertainment apps like YouTube and so on. Yes, there's a place for that. But if you look at the rest of the apps, which I largely classify as information apps, those would be Wikipedias, Yelps, so on and so forth, and you abstract what they are doing out, you'd learn one thing very quickly, is that the information that they are sending to the user, either on the web or in their app, is coming from the same backend. Okay, so that's one level of abstraction. So now you go, well, then what's the difference between this thing and this thing? And you realize that to make that information feel smooth in their UX and to render it properly and so on and so forth, on one side they send a bundle of JavaScript, that's the web world. On the other side, the user chooses to download the render code, be it written in Java or in Objective-C, and that code is compiled into a APK or an app, and that just kind of sits on your device. So what you get is a far smoother 60 frames per second rendering on the app side, when JavaScript in a browser container ends up being really hard to actually deliver the same performance. So with that abstraction, you soon learn that an app is a far better interface to the same information bundle than a mobile website is, even though everyone's pushing boundaries on all sides. And once you realize